day to our viewers. Today, for the heat transfer subject, we are going to look at laboratory to radial conduction. Well, to make it simple, radial conduction is when conduction occurs in a cylindrical object or a circular object. Well, conduction is something where when heat transfers from a hot region to a cold region, and this type of conduction occurs in a circular or cylindrical object. Well, next, let me introduce our team members. Our team consists of 4 people, which is Muhammad AMIR IRFAN bin Muhammad SHUKRI, MUHSIN AMILI bin NOOR, me, RUSHAN, anak laki RANGANATHAN, and also Muhammad AIMAN bin RAZAK. We are going to talk about different parts when we conducted the radial conduction experiment. Okay, once you're doing a lab or a study or an experiment, for sure there's an objective. Well, for the radial conduction lab, the objectives are very simple, and it gives us how do we apply radial conduction or even heat transfer in our daily lives, and it gives us a simple picture on how heat transfer is done. Okay, for this radial conduction lab, the objectives are to determine the constant of proportionality of thermal conductivity for one-dimensional steady flow of heat, and to comprehend how to calculate thermal conductivity for materials. Well, these are the main objectives for the lab. Other than that, we also learn on ways to analyze data, collect data, and then group the data accordingly, so there's a comparison between our actual and also experimental results, which will be helpful to determine and analyze the data carefully for any future projects. My name is RUSHAN. I'm from BMMH. Today, for the heat transfer subject, we are going to look at the radial conduction lab. Well, before me taking you further, let me ask you a question. What do you think when the word radial comes and conduction? Well, for me, when radial, I remember of something circular, maybe a cylinder, sort of things. Okay, when conduction is when heat or energy goes from a hot region to a colder region, or through successive layers. Well, let me take you further with the theory of radial conduction. Radial conduction, when it comes to your mind, you have to imagine the inner and outer surfaces of a thick walled cylinder are each at a different uniform temperature. A cylinder which is different, and it has temperatures at different regions, and heat flows radially through the cylinder wall. Radially through the cylinder wall, that means it goes through layers by layers and layers. In this experiment, there is a disc which can be considered to be constructed as a series of successive layers. Well, the disc acts as a simulation of the radial conduction. Other considerations in the radial heat flow through each of the successive layers in the wall must be constant if the flow is steady. But since the area of successive layers increase with radius, since it's a cylinder, it increases with radius, the temperature gradient must decrease with radius, because the temperature is in, for example, the temperature is in the middle, and there are layers which go consistently around them. Okay, since the heat source is in the middle, for example, this pan, okay, this pan is the heat source, and there are consistent layers, so the heat transfer rate to each region or layers are lesser, and it will decrease as the radius increases. Okay, this this is what we meant with radial conduction. And furthermore, into this presentation or into this lab, we will discuss regarding the results, and also we'll do a comparison of data, so you will get a clearer picture regarding radial heat conduction.
Assalamualaikum. Our group are going to conduct the radial conduction experiment. First, we are going to open the pipe, and then we're going to switch on the main power. And then we're going to turn on the heater. Okay, after we on the heater switch, then we're going to open the valve. After all the preparation, we are going to start the power at 30 watt. We're going to adjust from here. So we are going to wait for 5 minutes to let the temperature stabilize so we can get accurate measurement.
Hi, my name is RUSHAN. Okay, once again, let us see at the data. So, the power is going to be eventually increased to, let us see, to around 50 watts. So, we'll use this knob here to increase the power to eventually 50 watts. So, we shall increase it slowly. Okay. Okay, once the power is increased, the temperature also will eventually increase slowly, where the T1 to T7 changes. And when it's stabilized, we can record the temperature in our data table as follows.
Hello. So after we get the data for 50 watt, so we increase the finalized power 90 watt. So we increase. Slowly. Go. Okay. So we wait for 5 minutes. After that, we take the data from the screen.
Alright.
Okay, with the data we have gained from the machine, we have to convert it from Celsius to Kelvin, and then insert to the table to find out to later segregate the data and get a plot. Follow us.
Hi, Assalamualaikum. My name is MUHAMAD RAZAK, and I will explain about the safety precaution, result for our labs, and some calculation. So, first of all, foods and drink are not allowed in the lab. Proper PPE and lab attire must be worn at all times. Stay focused and aware of your surrounding in case there is any emergency happen. So, and don't play around in the work area. Ensure work area is clean and tidy during and after work is done. If there any accident happen, you must inform it to the engineer in charge in the lab, and check all joints and connection before starting the lab work. Follow all safety operating procedures, equipments before starting work. Wear glove when handling any heat, and maintain safe distance and sanitize hand before and after using equipment. So if we look at our results, the temperature will decrease when the thermocouples is getting far from the heat source. The temperature for each thermocouples will also increase when we set the heater power to the high watt. So in this experiment, we get curved line for our graph. This is our graph when we set the heater power to 30 watt. So in the calculation, we use the formula given to calculate the thermal conductivity K. After we get the value, we use it to calculate temperature for each thermocouples from T1, T2 until T7.
Hello, my name is MUHSIN and BMMH3553. Today we are going to discuss our discussion. For the first discussion, we have to choose sets of value. For our group, we choose 30 watt. Using the result we choose, we have to calculate the theoretical temperature from T2 to T7 using the formula given. After we calculate the theoretical temperature, we have to add the theoretical value to the curve to compare your data, experiment, and the theoretical value.
Hello, my name is Muhammad IRFAN bin Muhammad SHUKRI. So for my part is discuss the cause of error between the theoretical and experimental data. The practical error that may cause a contrast between theoretical and experimental data are as follow but are not limited to the following, and some error may also be caused by the calibration of the equipment sensor, which should not be taken account at the moment of the experiment. As you can see, thermal energy may be lost to the surrounding. The experiment was done in an open environment, and we are not able to control the surround temperature. And since the room is air conditioned, it could be a factor energy loss to surrounding. Second is proper physical contact may have not been achieved. The physical contact between heating element might have not been achieved fully as there is no warm-up time for the equipment. Third is impurities or sedimentation may cause heat to flow non-uniformly. Due to long-time users, there might be some impurities or sedimentation present which may cause non-uniform heat flow causing difference in data. And lastly, color of material and type or shape of material affect the radiation coefficient. There is also a deciding factor as a darker color paint will have a higher radiation coefficient and better thermal conductivity. That's all from me. Thank you.
For the conclusion, we have concluded what we learned based on the laboratory activities. First, we are able to learn the heat transfer concepts such as conduction, convection, and radiation. Second, we learn through the lab, we are able to apply basic law of heat transfer by conducting through cylindrical solid to be investigated. Third, we are able to apply Fourier law to solve missing parameters in the experiment to segregate the data accordingly. Number four, this lab able us to understand on how heat conduct uniformly around a solid disk of uniform dimension. And lastly, we are able to prove that thermal conductivity is inversely proportional to the temperature regard to the distance. That's all for me. Thank you and Assalamualaikum.